Hey everyone, in this episode, we're going to take our enemy animation up a notch using the animation tree. Now, the animation tree allows you to utilize individual animations that you would have in an animation player, but blend them with your own creative logic and states. We're going to start within our enemy scene, and we're going to be adding an animation tree node to our scene tree. Go ahead and go to the root, and then we're going to add animation tree. Once you have that created, we want to go into the inspector on the right side and select the animation player that we have within our scene. You'll notice that you now have an animation tree tab on the bottom. Right now it's empty because we haven't decided what the tree root is, but we can do that now. The tree root is that first option on the right side in the inspector, and we have lots of different options in here depending on how complex you want this animation tree to be. We're going to use a animation node state machine. This is going to allow us to categorize our animations into different states. For this episode, we're going to split those into what we currently have for our states in our enemy, which is idle and follow. Within an animation tree state machine, you can add any of those other roots, including just a basic animation or a blend space 1D, which blends between two different animations, a blend space 2D, which can blend between multiple animations, a blend tree, which offers node-based logic, or just add an entire state machine. Eventually, we're going to be using the blend spaces, but we're going to start with a blend tree because this allows us to customize them a little bit more. So once you have your state machine set as your root, we'll go ahead and right-click and add a blend tree. This blend tree is going to be called idle, and then we can connect our start node into that first idle state by using the connect node. We're going to do a one direction connect, and that's going to be an automatic. So if you click on that connection here, you'll notice that you can do an advanced mode. Auto means it's just going to go, as well as some other options that we're going to be looking at in a little bit. Now let's click into this idle state, and you're going to see that we now have a node graph. We have an output, which we want to eventually get to, and then we can add some different nodes in here. The first thing that we want to add is an animation node. That's going to allow us to select a specific animation within the animation player that we're assigned to. And for this one, we're going to have our fighting idle that we did in our last episode. We'll take that and we're going to connect that to a TimeSeek. Because we're working within the animation tree, we have to utilize its logic for some stuff that we would normally just use in the animation player. Now in our script, when we start our animation, we're doing a seek, and this allows us to randomize the starting position of the idle animation whenever we load the game. So all the enemies aren't doing the same exact thing when we start. Now that seek is not going to work because we're using the animation tree, because the animation tree has its own way of handling that. That logic comes from the TimeSeek, and we're going to have to get to that in a different way as well, but we'll get to that when we start adding the script logic. So we're going to take that TimeSeek and then we're going to connect that out into the output. And now we can also play with this a little bit just to show you how this works. So currently this transition is set to auto. So if I set this to disabled, that means that is not going to just automatically go from start to the idle node here. Let's go back to the start. You can do that by pressing that play button, and you'll notice that our little model dude here is no longer animating. Now, if we go to our idle, we're now playing our fighting. So in the case of a state machine, we're going to have a starting point, and we're going to travel automatically. So we do that by setting this to auto into that idle state. Now, the idle state doesn't travel unless we have certain things going on. In this case, that's when we go from our idle to our follow state. So let's keep building this out. We're not going to do any of our scripting stuff quite yet. We need to make the next state, and that's going to be our follow state. And really for what this is going to be, it's going to be more of a chasing state. So what we're going to do is we can actually take the transition here and drag that over and then add a new blend tree. Call this one our follow state. And for this type of transition, we want to be able to go both ways. So we can also drag that with our transition and set both of these instead of auto to enabled. So now we have a way to go to follow and back to idle. Now we can head into the follow state, which is another blend tree like we just did, except this time instead of just grabbing the animation, we want to be able to blend between idle and our walking animation. So we're going to right click, and this time we're going to do a blend space 1D. Okay, we're going to name this idle chase blend. And then let's go ahead and do another TimeSeek so we can control where this starts, and then back to the output. Now let's open up the Blend Space 1D editor, because this is a little bit different than just playing an animation. So how this works is this is a 1D graph. It basically goes from whatever your low end value is to your high end value. You can determine both of those values yourself. And as you go from one value to another, it's going to blend the two animations together. So the first thing that we can do is we want to set these values differently. Because we're going to be using the enemy's velocity, that is something that would go from 0 to whatever the max velocity is, we want to set the low end to 0, and then the high end would be 1. So 0 would be idle, 1 would be walking. Next, we want to add the two different points at 0 and 1. So we add a 1 to 0, that's going to be an animation. You can also do another blend space or a blend tree. It's kind of crazy how varied you can do any of these setups, because everything can fit into its own thing, sort of like animation inception. But we're going to add idle to that low end and make sure it's at 0, and then add another animation for walk at 1. Now, if I go back here and make sure that we're playing, I'm going to switch this to follow. We're going to open this up, go back to our editor, and you'll notice that I can now blend between those. And doesn't that look pretty cool? We can now blend between our idle and our walking. So any variation in between, right? We got kind of a almost walking, we're halfway between, but we're keeping that animation transforms and gradually shifting between them. Super cool tool. So we have our two states and we have our blending set up. Now we need to be able to utilize the animation tree using our script. We're going to do that in really two different ways. One is we're going to travel to one of these states, and then the other way is that we're going to use a blending alpha to go between these two different animations while we're in the following state. So instead of just abruptly stopping and going, we're going to blend between these. First, we need to get a reference to the animation tree. So that's going to be a onReady. We'll do animation tree typecast to animation tree, and then get the animation tree and get the node location for that. So you can always do that by just dragging and dropping that in there. We have the animation tree. We also need to get access to something within the animation tree. Now, the animation tree, at least within the script, is a little bit awkward in how you have to interact with it. So there's something called the state machine playback, and that's the state machine tree that we're using within the setup. So we're going to create a variable here called animation state, and this is going to use the animation, this is a long one, node state machine playback. And this is what's going to allow us to decide what state we want to go to. Now, in the last episode, we used the animation player, we set the animation, and then we did a random seek. We're going to get rid of that. The animation player holds the animations, and the animation tree controls how we utilize those animations. So instead of all this, which I'll just comment out, we're going to go up here, and then we're going to set our animation tree state. And this is going to equal the animation tree. And then the awkward part of working with this is parameters / playback. So if you go to your animation tree, there's a little drop down here for parameters. And this is what we need to get to. We're all trying to get to these properties. And the way to do that, unfortunately, is to use this string path. So we're going to get parameters playback for our animation tree state. And then we're going to wait for the process frames. We're going to go to everything loads. Now, the first thing you'll notice is that we don't need to manually set the idle animation, because in our animation tree, as soon as we start, that's where we go. We're automatically going to go to idle. But with our animation tree state, we can go down to our follow state where we are setting our walking animation, and we can replace that. So down in our on follow state physics processing function, which runs when we're in the following state, we have if animation player, animation current animation is not walk, animation player, play, walk. So we don't need this, comment that out. So instead we can use the animation tree state to check what the current node is. And if that current node does not equal follow, then we can go to the follow state. And we do that by using the travel function and to follow. So this is the same thing, just the same thing as our going into the walking animation. It's just because we're in the animation tree, we have to utilize this state machine node logic. Now, in fact, we can probably move this to the very top. And when we do the next episode, which is going to be focused heavily on getting all of these state behaviors really synced up and working, and we're going to add an attack state to that as well. We're going to adjust a little bit how we're going between these different states. So I'm going to go back to our prototype level and let's add in one of our enemies. Simple enemy, got our T-pose. He's already in our idle animation state. Put him there. Let's play. We should be able to approach him and he moves into our walking animation right away. Now we haven't set the logic for the blending and we haven't set the logic for getting him to switch back to idle, which if he's not moving, he should blend into our idle pose, which we're going to do that next. But we do have the animation working. So when we get in there, he goes to our walking animation. Now, the cool thing about the animation tree is that we don't have to just sit here and blend between two different animations. We can have properties of our enemy, that would be the speed that the enemy is moving, and have it affect the blend of this animation. So if the enemy is moving slowly, they might be moving around here. If they're moving all the way full speed, they'll be fully walking. We're going to do that by adding a function to our script that's going to update this blend amount, this alpha from 0 to 1, based on the speed of the enemy. So let's go back to our script and we can go ahead and add this at the very bottom. That's fine. I'm going to paste in what I have, and this is going to be called update blends. And within this, we're going to get a move amount, which is based on the velocity length. That would be the speed of the enemy. And then we're going to remap the move amount to a min max of 0 to follow speed to our blend values of 0 to 1. So just remapping the enemy speed to something between 0 and 1 for our blend. Then we need to get the animation tree, get our parameters, go to the, and this should be follow, and then idle chase blend, which I'll show in a second, and then blend position. So this is, again, the awkwardness of the animation tree. But once you get used to how this works, it's extremely powerful. So if you look on the animation tree on the right, we have our parameters, we have follow, we have idle chase blend, and then blend position. And if you hover over the property that we want to actually adjust, you can get that parameter path. You probably can't see that because it goes off the screen, but it's exactly like that. So we're going to set that value to our remapped move amount. So we save that, and then we need to run this every frame. We'll put this in our physics process. We'll update our blends every single frame. Now we do have to make one change in order for this blending to even work. So currently we're trying to get the move amount from the length of our velocity. Well, right now that velocity is basically always going to be the follow speed. We're taking our direction and we're always multiplying it by our follow speed. We don't have any acceleration. We don't have any deceleration. Because we're using the nav agent, which really has two different ways that you can set velocity. One being just the default way. You set the velocity for its pathfinding. The other way is to do on velocity computed, which is how we do the avoidance. This is how we keep enemies from running into each other. So we're going to set both of those, just for whichever version that you want to use. Now, if you want to be able to switch between using avoidance and not having avoidance, for your avoidance within your velocity computed, you want to use this script. So target velocity, we're going to use the acceleration if the velocity is greater than 0.01, otherwise decelerate, and then we'll move toward the target velocity for both X and Z. Now, down in the physics processing, we want to make sure we still do a nav agent velocity setting, otherwise the velocity computed thing is not going to work. In the case that we don't want to use avoidance, which this can actually go also in here, that is if not nav agent avoidance enabled, then we want to just set the velocity of our character body 3D. And we do the same thing, get the target velocity X and Z according to direction, multiply by the speed, and then set our velocity by moving toward the target velocity with our acceleration and deceleration. Now, in this case, both avoidance and no avoidance will work. And we're going to get our blend, which I can show you now with avoidance. We've got two enemies set up. And as we get close They're going to blend between, and as it gets closer, it's going to go back to our idle slowly, and I move away. It blends back to walking, and we can have this guy right over here do the same thing. And now we've got a much more fluid animation system for both. See, doesn't that look good? We can even move that target distance a little bit further away. Test the same thing. Look like they're ready to go at you. Perfect. So that's utilizing the animation tree, using the blend spaces, using the animation tree state machine to start blending between the animations that you have on your imported model. Now, in the next episode, we're going to add an attack state and an attack animation, and we're going to adjust the behavioral logic to go between our idle, our follow, and our attack states. As always, the source files for this are on my Patreon. You can download those there. Thank you to all the current supporters. We're going to keep crunching along with these tutorials and start fleshing out this game loop. As always, thanks for watching and keep creating.